Hello everyone, myself Rahul. So today I'm going to solve a problem called next permutation. So the problem is something like this. A permutation of an array of integers is an arrangement of its members into a sequence of linear order. So for example, array is given as 1, 2, 3. So following are the permutations of this particular array. So we have to basically rearrange the elements in some particular order. So 1, 2, 3 is also a permutation of this 1, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. Right, so we have to use the same integers that are present in this given array, and we have to somehow jumble those integers here and there. Right, we have to finally find the next permutation of an array of integers. And what is the definition of next permutation? It is a next lexicographically greater permutation of its integer. More formally, if all the permutations of the array are sorted in one container according to their lexicographical order, then the next permutation of that array is the permutation that follows it in the sorted container. Alright, if such arrangement is not possible, the array must be rearranged as the lowest possible order, that is sorted in ascending order. So if we can see for an array given as 1, 2, 3, what are the possible permutations? So these are what the possible permutations are: 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, and 3, 1, 2, and 3, 2, 1. Right, so we just need to find what is the just greater permutation for the given array. So 1, 2, 3, for this array 1, 2, 3, what is the just greater permutation? It will be 1, 3, 2. Right, so these are also the greater permutations of the given input, but we need to find whatever is the next available greater permutation. Right, so in this case I have to return 1, 3, 2. Similarly, if the input array is given as 2, 3, 1, so as I can see, the number represented by 2, 3, 1, which will be smaller than the number represented by 3, 1, 2. So I will be returning 3, 1, 2 over here. Similarly, if the input is 3 to 1, so this is already the maximum number that I can form using these three integers, right? So in this case, it has been mentioned that if no next permutation is possible, then I just need to return the smallest permutation, which is nothing but the array sorted in ascending order. So I will return 1, 2, 3 in that case. Right, so yeah, that's pretty much the question. So we are given an array of integer nums. We have to find the next permutation of nums. So we have to modify the input array itself. And the other thing is the replacement must be in place, and we only have to use constant extra memory. So we can't use a new vector array, and we shouldn't return the new array that we will be creating. So we have to do whatever changes we are expected to do in the same input array only. Right, so let's try to understand this using a better example apart from this. So in this they have taken an example 1, 2, 3. So I will try to consider another example. So let's suppose the input array is 3, 2, 7, 6, and 5. Right, so here I want to compute what is the next possible iteration or the next permutation for this given input. Right, so here we are given an integer array. So these are nothing but the array elements only for at a particular index. But if this was a single integer, so 32765 was a single integer instead of a vector, then what will be the number which will be just greater than this number using the corresponding digits? So in that case, that number would have been 3, 5, 2, 6, 7. Right, so this is what I would have to return, and this is nothing but a array in itself. So these are the indexes. So this is what I am expected to return finally from this input array. Right, so for one of the solutions can be the brute force approach can be. Right, so whatever that is mentioned in the question itself, that given an input I can find what all possible permutations can be there for that given array. So I will be finding all of these permutations, and then I will be one by one checking which is the just next greater permutation for that given input. Right, so that will be very naive solution, and the complexity would be very high. So we have to think of a better solution in this. So what can be the better solution here if we somehow think that like if we have to find a number which is just greater than a given input, so we are expected to change some of the indices, like we need to swap some of the digits here and there, right? So that swap has to be preferable if we are doing that swap in the end of the array, right? So given this input, right, so there are multiple greater elements, greater possible arrays that can be formed. Suppose I start the array with 7, and whatever the elements I just place after 7, this complete array would be greater than this one, right? And if I start the array with 6, similarly 6, suppose 6 5 3 2 7 6 3 5 2 7, whatever we can place after 6, because 3 is less than 6, right? So these are all the possible answers, but we need to find whichever is the next greater element, which is this one, next greater possible array, not element. So let's take this input array only. So the input array is 3 2 7 6 5. So what I meant is that we need to start looking from the end of the array whether I can swap some of the elements so that the resulting array would result into the just next greater array, right? So beginning from the end of the array, I will see second last element. Let's start from the second last element from the array. So I will see whether I can swap this 6 with this 5, right? So suppose if I swap 7 2 5 6, this would not result into a greater array, so this is not a possibility. Then what I can do is I can see go one step back again. I will compare this 7 and 6. So if I suppose swap 7 and 6, will that result into a greater array? No, it will not. So it will result into 3 2 6 7 5. This is also not a possibility. Then I will see if I can swap 2 and 7. If I swap 2 and 7, the resulting array would be 3 7 2 6 and 5. Yes, it is a greater array than this one, right? But we can't directly swap 2 and 7, although it is a greater array. But we can still need to optimize this solution or find the next greater array, right? So we have somehow reached this particular 2. Here I am able to identify, let's call it index I, and I'm able to find an index I such that the value, so let's call this array as nums. So the value present at ith index is less than nums of I plus 1. Right, so firstly I have to find that particular I starting from the end of the array such that this condition is valid. Right, so I am able to find this particular I. Right, so I is my at this position. So I need to swap this 2 with the element with a number which is just greater than 2. So the number is 32765. So in this array, what is the number present to the right of 2 which is just greater than 2? So if I can see 7 is greater than 2, yes, it is fine, but there are numbers which are greater than 2 but still less than 7, right? So I need to find those numbers. So I go to further right, then I look at 6. 6 is greater than 2 and it is less than 7. So 6 would be making much more sense to swap with, right? So instead of swapping 2 and 7, if I would have swapped 2 and 6, 2 and 6, right? So it will be 2, 7 over here, and 6 and 5. So this is again a greater array than this, but and it is less than this. So this is making much more sense in my answer, right? But I still need to go to the right of the array. I can see that 5 is still greater than 2. So can I swap 5 and 2? Yes. So if I swap 5 and 2, sorry, I swapped it wrong. It is just like this. Yeah, if I swap 5 and 2, 3, 5, 7, 6 and 2. This is again greater than this and it is smaller than this. So this answer is making much more sense than the previous one. Right, so this is what I have to return. So somehow I have to find that particular index in this particular array. So let me write it again so I can explain better. So 3, 2, 7, 6, and 5. Right, so I am able to find that particular I at which this condition is valid. Now I need to find a index j such that the second point is, this is first point, the second point is such that uh, nums of j, it has to be greater than nums of I, right? But this while finding this j, I need to continuously check that this j should be the optimized one, right? If I am starting iterating from the end of the array, suppose I am initializing j with the end of the array and I am checking 5 with this I, so j value would come out to be this last index only, right? So I will be returning this j, right? So I have now find this I and j. Now I can swap this I and j. So after, now if I swap, so the resulting array would return come out to be 3, 5, 7, 6, and 2. I've swapped these two elements, right? So 5 comes here, 2 comes over here. If I see here that this array is greater than this, but it is still not the optimized one, because this part of the array 7, 6, 2, I can still optimize this part to 3, 5 by placing these 7, 6, 2 into the increasing order, which can be 2, 6, and 7, right? So this is my final answer that I have to return. So I need to reverse this array 762 to 267. I need to reverse this array, whatever is present after ith index. So I was over here, so whatever array was remaining after ith index, I will just basically reverse that part, right? I hope the solution is clear. I will quickly code this thing. So most of the thing is like the complex wise it is a bit tricky, but the code is much simpler than the logic. So I will quickly code this in C++. So I'm going to create some variables I, j, and n. N can hold the length of the array, right? And I can initialize I with the second last index minus 2, because somehow I need to find this particular I where nums of I should be greater less than nums of I plus 1, right? So I need to find this particular I, and I will write one while loop while I is greater than equal to 0 and sorry, and nums of I is greater than or equal to nums of I plus 1. If it is greater than, then I'm going to continuously decrease the value of I. So let me just quickly tell you that. So I'm initializing I from here. If the value of, sorry, I from here, the second last index, I'm checking this in value is greater than or less than the then the next index. So 6 is greater than 5, so here I won't be I will be decrementing this I will be decrementing this I. So nums of I is greater than, so 6 is greater than equal to 5, so I will be decrementing I, right? So in this way I will be reaching this particular 2, and after reaching this 2 I realize that the value present at the ith index is less than the value present at I plus 1th. So this while loop I will be exiting, right? After this I can check if while one second, I can check if I is greater than or equal to 0, then only I am going to write the further steps, right? So here I need to find my j, right, which is nothing but which is value just greater than nums of I, right? So I am going to initialize my j variable with the last index, which is n minus 1, right? And I can write one while loop, and in this while loop I can compare nums of I with nums of j. If the value present at ith index is less than the value present at the jth index, which means if it is greater than or equal to, then I can keep on decrementing this, otherwise I will be exiting that loop. Right, so now my j would be pointing over here, because the value present at jth index is greater than, right? So this while loop won't be executing, so my j would be present at the last index. Now I need to swap whatever value is present at the ith and jth index, so I can pass I and j over here, right? And the last thing I have to do is I need to reverse the part of the array which is present after I plus 1th index. So after I have swapped the value present at I and jth index, this is my array, and then I need to swap the values present at, not swap, the reverse the part of the array present after I plus 1th index. So this is my reverse part, right? So I can write a reverse function, and in this I am going to pass this nums vector, and I can also pass the starting index from which I am going to reverse my vector. So I am passing this I plus 1, which is this index, right? So I need to write this reverse function. So firstly, before that, let me write a swap function which is not going to return anything. Here I'm going to pass this vector as reference, so that's why I'm using ampersand over here. And suppose x and y are the indexes. I'm going to create one temp variable which will be holding the value present at x index, and nums of x can be assigned as nums of y, and nums of y can be assigned as temp, right? This way we will be reversing the two values present at two indices in a vector. Now how the reverse function will work? The reverse function, in this I'm going to similarly pass the vector and the start index from where I'm going to start reversing the array, right? So what will be the end of the array? End will be nothing but nums dot size minus 1, and here I can write one while loop, which will take care of my termination condition. So while start is less than end, I can swap it. So swap nums of, here I need to pass nums and two indexes, right? So what will be those two indexes? Start and end, and I need to increment start and I need to decrement end. That's how the reverse function works, right? So I'm keeping two pointers over here, one from the start and one from the end. I'm reversing these two, swapping these two elements, then I'm incrementing start and decrementing end, then I'm swapping these two, then I'm incrementing again start and decrementing end, right? So that's how the reverse function works over here. And as I pass it by reference, so nums vector would automatically will be taken care of, right? So I don't need to return anything over here. I guess this looks fine. Let me try running this. Yeah, it is fine. I will submit this. Yeah, yeah, solution looks fine. So here, like we have used a simple arrays concept. So there is no any special data structure that we have used. So it was a mostly, I would say, greedy approach that we have to reverse. In order to find the next greater permutation, we have to somehow start from the end of the array to find if there is any element that we can swap with. Right. So I hope the solution is clear. And if you have any questions or queries, then you can definitely ask in the comment section, and I will create a ID1 link for the solution that I have used. So I hope, yeah, I will see you next time with another problem. Thank you, everyone.